Going to add. So my distance is going to be what?
13.
All right. So everybody always remembers distance. Distance adds. So distance is 13 miles. All right. So what do we do for displacement?
You got to do x squared.
All right. It's a triangle. So when we look at this, I walk 10 miles west. So I walk 10 miles west, and I walk 3 miles south. So west, 3 miles south. And several people said it's a triangle. Okay? So if it's a triangle, I know that I have to use a squared plus b squared equal c squared. So 10 squared plus 3 squared equal c squared. So 100 plus 9 equals c squared. 109 equals c squared. Square root of both. What's the square root of 109? 10.4. So c equals 10.4, which means my displacement equals 10.4 miles. All right. What on earth are we going to do with number 3? Serenity runs 1,600 meters in 6 minutes on Monday.
You find the mountain.
And then runs the same 1,600 meters on Tuesday in 5.4 minutes. How much does your speed increase on Tuesday?
Bigger and both out.
Figure out what the speed is on Monday.
Okay, so you figured out the 2 speeds? All right, it says that she ran 1,600 meters in 6 minutes on Monday. And then she did what? She ran 1,600 meters on Tuesday and that time, right? So how many speeds do I need to find? I need to find 2 speeds. And I want to know how much did her speed increase. So I'm going to need to do what with those 2 speeds? If I want to know how much it increased. Not add them, subtract them. Okay? So if I take Monday, okay, how far did she run Monday? 1,600 meters. How long? 6 minutes was her time. Okay, on Tuesday, how far did she run? She ran 1,600 meters again. How long did it take her this time? 5.4. Now, we have to find both speeds. So 1,600 divided 6 is 266.6. And 1,600 divided 5.4 is, whoops, 296.2. Now, what can you tell me between Monday and Tuesday? Did she get slower or faster? She got faster. Okay, so now we're going to take these 2 speeds and we're going to do what with them? We're going to subtract them. And we're going to figure out what she did faster. So 296.2 subtract 266.6 and we'll get 29.6.
Yeah, I see it now.
Does that make sense? Anybody lost by what I did? Yes, no? Because we're going to do some math practice later today. May have to have homework tonight. We got to finish the lab and we got to learn about velocity and acceleration today. I told you it's called SMAth. Do you remember? Fourth period renamed it. It's called SMATH.
I can do math in here than I actually do math.
Yeah.
All right. Now, if you will, rather than doing the lab first, let's talk velocity. Let's do some notes first, then we'll break and do the lab, then we'll do acceleration again. That way we break it up a little bit. So, if you have not got your openings for tomorrow, round them up, because I'm not giving you a half hour to find your openings tomorrow. So, make sure you've located them. If you've been absent, okay? With the exception of Alize, who joined us late, and I think she came in 2 days late, so she only gets to be missing 2. The rest of you have to have openings. So if you've been absent, okay, in here, if your first section is chemistry, so flip past that. Okay, they're in order. Come on. They work. They have the date, the day, and the subject. There's the very first one we did. You can just flip through the pages and go to the one you're missing and complete your opening. If you care. If you don't, that's okay too. Each opening, if there's 10, is worth how many points?
10.
10. If you're missing one, it drops to a 9. Okay? There's the one we just did, which is number 9. Any questions about that?
Yeah.
If you're absent, you're responsible for getting the one you're missing. If you just didn't bother to do it, the one you're missing is in the notebook. Okay? I keep them for the whole semester. I'll throw them out after you turn in tomorrow's openings. Now, if you will, find your notes. We're going to do velocity, and then we'll do the lab, and then we'll break and do acceleration. Now, and while we hunt up our lab in a couple of minutes, remind me and I'll hand out those other papers. All right, let's get rid of that. Velocity is pretty short. The nice thing about velocity is it's just like speed, so the calculations are pretty easy with the addition of one new skill. We have to talk about combining velocities. It's not hard. Acceleration is the only one with a different formula today. Find your orange card though, because I need to show you how the formula for velocity works, because it's written down different than the way we did speed. What kind of graph is that?
It's average speed.
All right, William can't answer. How does William know it's an average speed graph?
Because it's not straight.
It's not straight. Everybody okay with that for the test?
Yeah.
Okay. Okay. They cannot answer. So Jacob, Logan, and William, who I heard from, cannot answer. Okay. What kind of graph is that one? How'd you know it was constant speed, Nathaniel? It's straight and what? What's the other word we use? Straight and, remember the other word y'all wrote down? On the paper I'm getting ready to hand back? Somebody help him.
Diagonal.
Diagonal. Straight and diagonal are the 2 words you guys used. Okay? All right. I'm talking about velocity today. All right. So, what is velocity? Anybody know? Y'all ever talk about it in middle school? Anybody remember? Nobody? Okay. It's all right. I didn't expect you to know a lot. All right. Velocity is defined as speed with direction. Okay? It's speed with direction. That's how it's defined. Okay? Speed with direction. Okay? Velocity is speed with direction. Okay? Speed with direction. So, how is velocity different from speed? Now, based on what I just wrote in that definition. How is it different? William cannot answer. He talks all the time, nor can Logan. Those two answer all my questions. They cannot answer. I need somebody other than nor can Jacob. Those three answer all my questions. I need somebody to be brave other than those three guys.
When the thing, did him and Bree both answered the last question about the crowd?
But they don't always answer.
They don't always answer. With you three quiet, they're more likely to answer. I need somebody other than them to be brave and offer an answer. Alexis almost answered, and I got excited for a moment, and then she decided she wasn't going to. Yes, Bree.
Don't laugh at me, my mom.
Okay,
Okay,
I don't
so,
laugh at anybody.
Speed, okay, velocity is speed with direction, and speed doesn't have no direction.
Exactly. Exactly. Okay? Okay? Speed does not have direction. Velocity has direction. I told y'all the first day, probably don't remember this either, that I would not laugh at answers or questions, and y'all needed to not laugh at answers or questions either. Last year sometime, I had a student who tried to convince me that I could feel the breath come through the cell phone, and I just had to be really patient, and I could feel, like my daughter called, she would feel her breath come through the cell phone. I could never convince her that was not the case. But I did not laugh at that, even though that was the most ridiculous thing I'd ever heard.
My brother keeps trying
I
to
got
get
told
you
that
that.
there is like this month.
Huh?
When we took me computer run off this month.
That's not true either.
But it was a teacher that told me.
What?
Are they a computer teacher?
Whose computer did you
Miss
use?
Miller.
I'm not smoke. I hadn't heard that, but I'm not an electronics teacher, so I could be wrong.
Mrs. Miller said computer run off this month.
Tell me what this word is. What's that word?
Yes.
No, it's not. It's a yatchet.
Yes, it-
Yeah, what the-
yeah.
Yeah.
I didn't laugh when somebody told me that was a yatchet either. So I promise you, just because you give me the wrong answer, I'm not going to laugh.
It's better to get it wrong.
So
It's better to-
be brave. I'm not going to laugh at what you tell me. So it is a yacht, by the way. It's not a yatchet. Now, is velocity a scalar or a vector quantity? What did we say last week?
Hey, Dad, Logan, shut up.
Okay. You three still can't answer. So think about what we said last week. Scalar and vectors. Bree now can't answer either. Taking her out of the mix. Okay? Scalar and vectors. The rest of y'all have to be brave. All right, it's a vector. Why is it a vector, Damien? That's right. All right. Velocity is a vector because it has direction. Okay, vectors have direction. So velocity is a vector because it has direction. Okay, scalars have no direction. So speed was a scalar because it had no direction. Everybody with us on that?
Yes.
Okay, now we're going to talk a little math. We're going to talk graphs and math.
I do want it, bro.
Everybody caught up? Do I need to wait? I can put it on my desk.
Oh, dang.
Put it on my desk.
No,
Oh, you're just playing it on pencils?
yeah.
Oh my God. Stop playing with your pencils. You look like you're playing with a phone. Formula. On your orange card. Tell me what the formula says. Because we are not going to keep writing. God, I'm scared the Jesus out of you. Now, if you look at your orange card, tell me exactly what the formula says. Because we're not going to keep writing it this way. V equals. Look at this. I'm trying to avoid you and almost fall over a trash can. I probably would. So V equals Okay, what else did it have in it, which is what I want you to tell me?
The triangle
That's what I want. The triangle. And what else?
and a D.
Over.
A triangle and a T.
Okay. Now, a lot of the formulas have these triangles in them. Okay? Now, do we have to write these triangles? No. But we need to understand what the triangles mean. Okay? The triangles, I've actually already told you what they mean. I just didn't draw the triangles. Okay? The triangles, you might have learned in math class, mean change in. Okay? So that means change in distance. Change in time. So, what does change in distance mean? It means if two distances, what do you do with them? What did we learn last week? If you have two distances, what do you do with them?
Subtract.
What did I tell you to?
Dang it. Yeah, William. It just.
All right. If there are two distances, you subtract them. Now, will there always be two distances, though? No. Sometimes there will just be one. So if there's just one distance, do you have to subtract? No. Okay? You don't. So you can write this formula as V equals D over T. It means the exact same thing. There's no difference between writing a V equals D over T or writing the triangles. The state writes the triangles there, so you know if there's two times or two distances, you have to subtract them. But it doesn't mean that you have to have the triangles. Now, because speed and velocity are the same, I told you last week, is the state going to write the speed formula there? No. You have to know it's the same formula. Okay? Does that make sense? Now, we want to write a constant velocity graph. Now, constant velocity is the same as what? Constant who? Constant velocity is the same as saying constant what? Okay. You're a little slow to tell me that. Constant velocity is the same as saying constant speed. So how did we draw this last week? All right, Raul's doing this. Now, there's nothing wrong with doing that, Raul. Tell me how the axes have to be. Label them. Okay. And what has to be on X? Yes, very good. Most excellent. Now, do we have to label it distance and time? Okay. Let's alter it and put velocity and time. Now, I'm going to open it up to let everybody answer this one. I know. So, think math class. Velocity and time. Okay? Velocity and time. And I'm telling you, constant velocity. Velocity is not changing. How would the graph have to look? What, Daniel? What kind of straight line? What kind of straight line?
Oh, there's no point.
Yes. Exactly. Okay?
That's fine.
Because you want it not to change. Okay? So that would be constant velocity. Now, how is that different from the one that we drew that was this, that was not moving? Okay? Because this one was not moving. That's right. That one had D and T. This is why I'm telling you guys, you have to make sure that you have the what on the graph. You have to make sure you label the X and Y axis. Because if you don't label the X and Y axis, does your graph tell me anything? No. So on your lab today, when we finish that, The whole back page asks you to draw graphs. If you don't label your X and Y axis, I go along and write -5, -5, -5, and you lose like 15 points because you didn't label your X and Y axis. Your questions are all wrong. So make sure you do that. All right, so increasing velocity. How does increasing velocity look? How are we going to show increasing velocity? Again, anybody?
Oh, then you just don't know.
Okay, so how am I going to label my axes? Who?
Velocity.
Velocity and time is fine.
Or distance.
Can we do distance and time?
Yes, because
Okay, how am I going to do my graph, though, to be distance and time? Well, I can't draw it that way or it'll be constant speed.
oh, then you just set up.
No curve. And I'll come back to that one when we get to acceleration. Okay? Because increasing velocity is actually the same as acceleration. So we will revisit that later today. Okay? We'll come back to those bottom two. I just want those to percolate in our heads. Logan, hush. You need to wait? All right, can I go now? All right, the rule that we need to talk about, this is the last rule other than basic math, is combining velocities. Okay? Did I write the rule? Nope, I didn't. I got to write it. All right. If two objects travel in the same direction. Okay? Same direction. We add the velocities. If two objects travel in opposite directions, you subtract velocities. And I'll let you write the rule and then we'll talk about how that works. Y'all have experienced this, even though you may not realize it. All right, caught up? What is that goo y'all are playing with? Stick it to anything.
No, it helps the,
I'm glad to hear.
everything happens.
If anything happens, it's whose fault?
It's fault.
Wow.
You don't wanna have it happen. You
Okay.
only got it on.
He's the one who brought it to school, so he,
I had it on.
that he still brought it.
Okay, it's his fault.
Yeah, just. He's got connect.
Okay. All right. So let's say we're going to use Bree's question when she came in about the hurricane. Of course, everybody does know there's a hurricane out in the Atlantic, right?
Oh, yeah, we're going to dog.
Okay. Miss Bowers didn't even know about it till yesterday. Y'all really need to pay attention to the news. I'm not asking y'all to follow politics or you know, some kind of- or anything else. Now, that is incredibly optimistic. Now, I'm not telling y'all that we're not going to feel the effects of the hurricane, because we are. And it's possible that we are certainly going to have winds. Now, for us to feel 80-mile-an-hour winds, we've got to be much closer to it. We would have to be on a direct line for the hurricane. Currently, we do not know where Hurricane Florence is going. Ms. Ford is not lying. Is a person who follows the weather regularly. She has no idea where the hurricane is going currently, because the weather forecasters do not.
I just seen.
The most likely track currently that they're projecting is coming in somewhere around Wilmington. Now, from there, who knows? But it could go anywhere from the north or part of North Carolina down around the middle part of South Carolina. But currently, the more prevalent thought is coming in around Wilmington. Now, given that, if it comes in as a Category 4, which is where it is currently, we are going to feel very sustained winds. But we're more likely to feel 50-mile-an-hour winds as opposed to 80-mile-an-hour winds. But because by the time it moves from there to here, the winds, the storm is going to fall apart and the winds are going to die down. The eye wall is where the greatest force of the winds are, and those are going to break down fairly quickly. We are not going to have the eye wall this far inland, so we're not going to get that type of sustained winds. 80-mile-an-hour winds are hurricane force winds. We are too far inland to feel 80-mile-an-hour winds. But yes, we're going to feel the outer bands, which are going to be sustained winds. When you walk out of the science doors, the doors are going to fly open and hit the walls. When you walk out of the indoors in the main hall, they're going to hit the poles. Those things are going to happen even at 20-mile-an-hour winds, which we are certainly going to feel on Friday. Yes.
I had to school first, and I checked it, the weather center, and it's saying that probably Friday, Thursday.
By Thursday, we're going to be hitting outer bands of rain.
Late Thursday, night, early Friday. It's gonna go directly over.
It depends on its track. But if the track is on the current track and it continues on the one that is most prevalent, then yes, it could go directly over us. But it depends. I mean, if you look at the weather, if you watch the channel, let's just say channel 12 news, and you see the forecast, you see where the hurricane's at, and it shows like 4 or 5 different models, and it shows it going this way, and it shows it going that way, and this way, and this way. Those are all of the different tracks or paths it could go on. And then it depends on the steering currents. It depends on where the different fronts are at. Right now, the most common theory is that it will come in at Wilmington and go over us. But that's not to say that it will. It was still 1,200 miles away this morning.
So are we gonna let not have school Friday?
It depends on Dr. Wells. I mean, you never know. I would say it will depend on the winds. It will depend on whether we keep power. It will depend on the amount of rain they're forecasting. It will depend on flooding. It will depend on all of those things. As far inland as we are, who knows?
Jim was saying that it might increase to a Category 5 because it's right there at.
It is possible. It went from a 2 to a 4 since I left the house this morning. It was a 2 and it's a 4 now, based on the weather alert I just got.
So yeah, you might feel actually.
It is entirely possible. We just have to wait and see.
They're saying they're something that if it does that emergency shelter, everybody can have to come to high school.
I will tell you this. In my 27 years of teaching, I have missed one day in college because of Hugo, and it came up through South Carolina and through Charlotte. That is one hurricane I've missed school for, and I think I've missed one other. So I would not bank my hopes and dreams of getting out of school this week for a hurricane, okay? I have missed very, very, very few days of school for hurricane weather. Okay, we're not on the coast, so y'all are counting on rain getting y'all out of school. How many days have we missed for school for rain?
None. But we are in a state of emergency.
Yes, but most of that applies down east.
Right.
We're 200 miles inland. I'm just saying. Okay, now it's possible, depending on the strength of the hurricane, its track, and what happens. But I would not put my eggs in the basket that we're getting out of school. Okay, it's just not very likely. Now my point in the hurricane is, okay, we have winds, right? All of us have driven somewhere. How many of y'all have cars and have to put gas in the cars? Gotta be fuel minded, right? Friends ask you for rides and you're like, dude, I ain't got the gas for that. How many of y'all said that to your friends? I used to back in high school. Even now, I look at people and I'm like, all right, not as stingy as I used to be. Okay? So, if, now y'all gonna have to make fun of my drawing, but I can't draw, so y'all just gonna have to deal. Hold on, I can do a little better than that. Okay. So, we got a vehicle, right? So, it's driving down the road. And let's just say, whoops, I just erased part of my truck here. Okay? The winds are pushing behind us. Okay? Now, let's say that we're traveling out on 85 and we're doing the 70 miles per hour because we're law-abiding citizens. We're not speeding. Okay? Not Miss Wall today. So, we're doing 70 miles an hour. And let's just say Hurricane Florence is here and it's pushing us. And the winds are blowing at 25 miles per hour. What do those 25 miles per hour winds do to us if they're pushing us from behind? That's right. They make us go faster, okay? It also helps our fuel mileage so that we don't have to push as hard on the gas pedal, and so we use less fuel. This would be an example of combining velocities. So, because the wind is pushing from behind us, what does it do? That's right. So what do I do with the two of them? Because they're in the same direction, because the car is going this way, same direction. That's right. You add them together, we would be doing 95 miles per hour. Okay? Because we would add them together. All right? We would have to slow down. We would have to use less gas and not push as hard on the pedal. Now, by the same token, let's say that we were going towards the coast. All right? And I had my same old rickety looking truck here. All right, and this time, Florence's winds were pushing at my front at 25 miles per hour. All right, and I am doing the legit 70 miles per hour because, again, I'm a law-abiding citizen. What happens this time? We got to subtract. So you'd have to say 70 minus 25. So you get what this time? What happens when you say 70 minus 25?
It's
45.
I was thinking it was 45 miles per hour in my head. Now, when we do that, who wants to be doing 45 miles per hour out on the interstate? Not me. So how do you compensate? Exactly. So what's that do when you do that? It does speed you up, but what does it do to the gas needle? It uses more gas, and your fuel mileage is terrible when you have to fight the wind going across the state. Now, have any of you ever flown before? Okay. Have any of you ever gone to the airport to pick anybody up, even if you haven't flown? All right. When you go to the airport, they have these big screens that give you arrival and departure times. Those are estimates of when the plane should arrive, right? Well, let's say it says you're arriving at 2:50 in the afternoon, and suddenly you see, oh, you're here at 2:30. Why on earth would a plane get there at 2:30 when you're not supposed to be there at 2:50? Exactly. All right. Sometimes, for example, have you ever heard about like jet streams? When you watch the weather, you should learn about this in earth science, by the way. But let's say you get into the jet stream, And the jet stream is a current of air that travels across the United States. If you get in the jet stream is going to help push and carry the plane across at a much faster rate. It's going to get you there faster because it's going to combine the velocities so you're able to travel faster.
Unless you're fighting it.
Now, if you're fighting it, it's going to do what to the plane?
Slow you down.
Slow the plane down. Okay? Now, I want to do one question. Write this down so we can talk about how you write your answer. Okay? Because the only thing that's different about a velocity problem and a speed problem is how you write your answer. So write that down. We'll talk about how to write the answer real quick, and then we're going to do the lab. Or finish the lab, I should say. Because you should have your data, so we should just be finishing the questions in groups. She's listening to something. There's nobody over there. Might be just Worley practicing because she sings.
Lucy?
Miss Worley.
Miss Worley.
Miss Worley. Meredith Worley.
Yeah,
She's subbing over there fourth period today. So she could be practicing. All right, so when you want to find velocity, what's the formula for velocity? Velocity equal distance over time, right? So what's the distance? 300 kilometers. What's the time? So when you divide, you get what?
60.
So 60 kilometers per hour. Now, when we write that answer, that's a speed. So what makes it a velocity? What did we say velocity had to have when we started this discussion? Direction. So look at your question. See how it says east right there? You have to write the word east on the answer. So when you answer a velocity question, if it asks you a velocity, you have to say the direction. Now, if it asks you to find distance or time, do you have to give it a direction? No, distance and time don't have direction. But if it says what is the velocity, you have to give the direction. Does that make sense?
Yeah.
Okay. Now, when you finish your lab, you're going to pick up a sheet for me on speed calculations. Okay? Now, I want you to find your lab sheet. You should have all of the numbers in the data table. Now, when we finished the numbers on Friday, some of you were asking me how to average, to do the average numbers at the bottom of the table. So I know there's a couple of you who are struggling with that. So, just to make sure everybody's on the same page, if you have a number like 1.67, 1.42, 1.38, 1.74, and 1.09, what do you do with those to find an average? Add them all up. So, 1.67 plus 1.42 plus 1.38. So I get 8.11.
Divided by 5.
And then you're going to divide by 5 because there were 5 trials, right? All right. So everybody's okay with how to do that? All right. Now, that was the only math that I remember people kept asking me how to do in the table. So if you or your group gets stuck, come find me. I know when you get to the last question, y'all are going to get stuck. So when you get to the very last question, come see me. Everything else should be pretty self-explanatory. Given the groups were large, there shouldn't be a group that's only left, I hope, to just one person. I know I've got a couple people out, but hopefully nobody is just down to one person in their group. Okay? So, find your group people and finish the lab questions. Hernandez, why are you going to sleep without a shirt? Find your group. Where's your lab sheet?
I don't know.
What?
Didn't you collect some?
I only collected 4 that I remember. I only got 2 of it in y'all's. Yeah, I only got some 4th period. They told me they'd lose theirs. You really don't have the one from the other day. Really? Okay, then you might want to come make it up. You got 0. Or look for it, it's easy to find.
Bless you. Thank you.
Okay. Whose group were you in Friday? John and Roy? I know Roy didn't lose his. You know, I thought one would lose it, not the other. Oh, hold on. Excuse me. Hold on. Put that back open. This is the missing lab. That's the one I'm hunting for that you didn't finish. Right there. Look, I'm going to set this over on my desk. I need you to come make that one up. See if you can find the one you're supposed to finish today. So we've tracked down one. That one you need to come do with me. Or at lunch. If you can find the one that's among the missing. Did you find yours? Look at it. Got one. You do. No. You're on the right day. There it is. Go, John. What?
We got to divide by 5 every average. For instance, time entry.
We did.
Guys, don't waste your time. You're not getting very long. By 1, you got to be done at the latest. By 1 at the latest.
Miss Hall,
Yes, ma'am.
I could come in here for third lunch and make up my test.
You missing a test?
I think it's a test or is it a quiz?
Oh, look, I'm in power teacher right now. Score sheet. You tried it. Last name and try it. Freshman 4th period. Your last name, Michael?
No, Vay. V-A-Y. It's the one with the measurements.
Why would I type in your name, do I not get you? Either.
It takes 20 days to read Really?
Yes, that's wrong, yes.
In my class? You're not there now. Look, you're gone. Go to attendance. You're not even on the attendance anymore.
I just came here to see if I could make up a sense.
Go in your power school.
That's what I'm doing.
A lot of ours are very different.
Yeah, Raul.
This is Monday, babe.
Meters per second.
You were here on Friday.
Yep, not that, says it was.
Second.
See, I am not crazy. I'm not nuts. Why is it? What was your last name? It wasn't hyphenated because you are not there anymore. I don't know.
So I just started going to her class now.
Let me see. That is my guess.
What? I'm confused. I've been going to her class.
Okay, so number one, it's my son that's explained, so I'm just gonna put a line.
Yep. Starting today would be my guess. Did they not call you to guidance?
No.
I'd go to guidance and ask. Yep.
Okay.
Go ask. Yes, ma'am.
So number one isn't telling us to explain anything, so I was wondering if I just put like.
Yeah.
I don't gotta explain. It's not telling us.
No.
That's, you want the same question as me.
They don't have to get me.
Well,
What?
explain number two.
Were all your speeds the same?
No.
Why not? One thing's gonna cause them to be different.
Yeah, I thought it was Marcus. You got it.
Yep.
If I take the string, we know what I'm talking about.
Yep.
You cannot turn it.
It was a liberty.
Since you just supposed to be taking a QR NBA. This one.
Yeah.
It's like, that was that might, that matters a lot.
You can cross the block or cross the street. As long as you play with right. At 9 or at 1 o'clock, y'all are done. Make sure you're finished. Yeah.
Hours is time. So if they have hours and time, do we cancel those out? And then you just use.
Say what?
You know how like, if they have, let's say the car went 400 miles and the next car was 200 miles. And so what's the time? And then you gotta cancel out.
Hours, so you'd only be left with off.
I guess the parts are used for.
The ones that do the running drive.
You got them? Number 4? Okay. A man child, per hour.
Let's go big down.
Okay, so this is going to be the 55 is the
So it comes around.
We're looking for
Flow master.
we're looking for the
These are flow master.
no, we're looking for what's at the top now? Maps.
Flow master. Fucking onboard that.
Right here. So far as
Every trip.
so far as
First week, I can't go find
Girl, Bob, man. That was Girl, Bob. Girl, Bob.
Have you seen?
No, no, kidding.
Big ass fan.
Okay.
Super.
Yeah. Right.
I'm talking about houses like that. I guess he's starting.
Oh,
That's why I don't, that's why people don't.
yeah. This is better than it can't be straight. Girl, Bob. Don't sit strong, girl.
What thing you can do?
Yep.
How do you do number 8?
Right here.
Take that.
I mean, she had to bring over.
Alright,
We gonna add those.
you've got it. Just set up, going straight up. Alright.
Yeah, so we gonna add all the,
As I said, you want another 2 hours.
add all
So,
the.
2 more hours, or 2 hours, right? So you add 2 hours away.
Right.
So go to 4 hours. And then go up another 15 kilometers.
Yes,
So, right? So you travel 30 kilometers in 2 hours. So, you're at 30 kilometers in 2 hours, which is here. You go over another 2 hours, or 4 hours, and you go another 15 kilometers. Instead of running 15, you're gonna add 15, or 30 plus 15, is 45 plus 2 hours. So you go on there,
This one,
and there. Yeah,
it's on him not your trust no more, so yeah, that's what I'm saying.
so what, you didn't take biology yet?
Huh?
I said you hadn't had biology yet?
No.
That's why,
So,
you just go to biology, because you hadn't had it yet.
that's such a waste of time. I
I'm
didn't
sorry, babe.
Yeah, that's the only reason why they use it. It's cheap.
So,
She
now you're gonna rest for an hour, so you do what? You go up. So, we'll stay there, go over 1, and then go another 45 and another 2 hours. Okay, but you're not going down, you're just, you go up. Okay? Y'all have 3 minutes, and then papers belong up here in the chair. Alright. Number, it's gonna be over like 2 hours.
I'm trying to hear y'all.
And stay at that 30. Okay, it tells you to go another 2 hours. Point there, over 2 more hours.
Okay, yeah.
And it says you can up 15 more.
Yeah.
You can up 15 more. And it says you rest, so go over 2 more. Okay? But you're always going over and over. Okay?
I'm gonna ask for
I don't know how to do it.
What's your name? Building. No, he's on the like.
That's what you can go for, staying in the rain.
Go 30 for 2.
Okay.
2 hours. You can go 15 more, 2 hours. You're gonna go 2 more hours. Up 15 more kilometers. You're going to go from this point on. You're going to add 15 more kilometers and over 2 more hours. You're not going to draw a point down here. You're going to go from there up 15 more and over 2. So you're going to go that way. And it says you rest. You go over to rest. Then it says you go 45 more. So you're going to take that point, you go up 45 more and over. Okay? Try that.
Hey, just look. Yeah, I don't want to see. I might get something.
Okay, so back to this one.
Yeah.
So everything adds 45 to 45.
Say what?
You add 45 to 45.
I'm gonna look them up. They are what you see in the junkyard.
Hey, I said that. What happened to one and two?
That's 50.
All right, lab papers, with the exception of the people who asked me that last minute question, need to be up here in my chair.
I put mine on the side. This how
All right, lab papers need to be coming my way.
I don't have mine to fix it up.
In the chair. Lab papers need to be coming my way. Daniel, y'all's group papers need to be coming my way. No, my way. I know, we're done.
Oh, yeah.
I'm not waiting on flow people because y'all been standing back there talking. Bring them up here. Bunch of y'all been talking, y'all don't get extra time.
It will.
Over here, man. Well, you do shit every week. You do shit every week.
Yeah.
Yeah, 'cause he got big money.
Make you have 80,000.
That was zero.
You had to put everything in because it broke down like 10 times already. You had to change everything on that bit.
I was sitting there, they gave me the whole mile.
Mine does. You're gonna put that paper
What she had done.
We don't have to put that.
What she had.
Well, the Yukon got seen. Okay. What is who? 150.
It can only be 6.
I generally get right at 100 of a day. Not much.
Like a minute?
No, right. 10 seconds.
Matt Cable.
It takes like 10 seconds for your Yukon to turn on.
Matt Cable.
It takes like 10 seconds for pros to take off.
Because it gets stuck.
He said his Titan will pull my keeper. His Titan is 2 whoop. Mine is all.
But we got. Maybe.
Well, yeah, I'll have to George.
Yeah.
I've told her 4 at 450. 4 at 450. Twice.
That's why that whole stack still sitting there, that whole. I got a copy because I have physical paper today. It's too hard to punch holes in it. I will, it just takes forever.
Yeah.
All right, you want to have everybody's lab paper?
Yes.
All right. Now, if you didn't finish, I'm sorry. But when I set a timeline and a time, y'all can't sit back there and just socialize and think, oh, she'll give me more time. No, I won't. Now, find your note. Let's talk acceleration. Now, tomorrow, after we practice, we're going to start working on another lab, and this one's going to require you to chew gum. Is there anybody who cannot chew gum? No? So I can see Sacramento's chewing gum, but is there anybody who cannot chew gum? All right, because I usually get double mint and juicy fruit as our 2 gums of choice.
Juicy. I like that zebra stripe, that old.
Mainly because I can get a lot of it and it's fairly cheap. I'm not buying $5 gum. Logan, where are you going? Let me think about it for a second. No. Move back. All right. if you look at your reference table, the acceleration formula is a little different than the ones we've done. But first, what is acceleration? Acceleration is the rate of change in velocity. Okay? It's basically how much velocity changes. Now, the way the state has given you this formula on your reference table, I'm really not crazy about, because it confuses a lot of people in some of the word problems. They have given you the formula as A equals VF minus VI over delta T. Okay? A equals VF minus VI over delta T.
That seems so confusing. I bet you
It's easy. Now, this is just time. The triangle again means what? Change in. Okay? If 2 times, you do what? Subtract. If there's only 1, you do what? If there's only 1, you just plug it in. Now, it's that VF and VI that looks a little weird. Okay? VF, Jacob, why are you not where you're supposed to be? Sometimes I let people move. Sometimes I don't. But right now, I'm not going to, so you belong. Okay. VF stands for final velocity. VI stands for initial velocity. Now, final and initial sometimes throw people off. Sometimes doesn't throw people off. Okay. What does final and initial mean to you guys?
Final means like what you end up with at the end.
Okay.
Initial is what you start out with.
Okay. So initial for us is first. Okay. Initial is the first velocity, and final is the what one?
The final, like last.
Let's just say second, since we got 2 numbers up here. Okay. Second or last, either one, doesn't matter. I'll just write second. So, given we're going to have 2 velocities, one of them is going to be first, one of them is going to be second. Now, the reason that I don't like this formula is, will we always have 2 velocities? No. And this formula implies that we will always have 2 velocities. Now, the formula I wish they had written is this one. A equals, what do you think I wish they'd written? How do you think I would have written that top one? What V?
Triangle. Triangle.
I would have written triangle V over triangle T. Why would I have written that? Because if you had two velocities, what have we learned yesterday and today we would do if we had two velocities? Subtract them. But if we only had one velocity, what would we do? We would just plug in. But this, people see this and they think we have to do what? You always have to subtract, but you won't always have two velocities. These two formulas are one and the same, okay? Because you're not always going to have two velocities, okay? Does everybody have that one off the board? Need some more time? Okay. Now, there are three ways for an object to accelerate. And I'll give you a moment to write that down. How can an object accelerate? That's one.
Really is.
Okay. William said speed up.
When have something be pushed.
All right. Have something pushing it makes it speed up. All right. We got that one. And we usually refer to this as acceleration. Okay.
Slope.
Say what?
Slope. Going down the hill.
Okay. So if we go down a hill, what generally happens? We go faster, right? That's covered in number one. What else can we do? Remember, the definition is how much velocity changes.
We just turn.
If we do what?
Take a turn.
Sure. That's the one that's hard for people to get. If you change directions. Okay?
Your height.
If I do this, I walk and I turn. I change direction. I change my velocity, therefore I accelerate. Okay? By definition, I accelerate. Who's in JROTC in this room? When you guys practice any kind of marching, when y'all get to a corner and y'all learn to turn, y'all accelerate every single time you do it. Okay? That's a form of acceleration because you change directions every single time. Okay? Speeding up, changing directions. There's one more. Change in velocity. How can we change our velocity?
Stop. Slow down.
Slowing it down. Okay? Slowing down has a name. There you go. When we slow down, we decelerate. Now, a lot of people won't use the word decelerate, particularly science teachers or physics teachers. They use positive and negative acceleration. I'm not that big of a stickler for the vocabulary, so I will use the words accelerate and decelerate because I hated physics in college, so it doesn't bother me to use the word decelerate. Now, is acceleration a scalar or a vector quantity?
Oh, it's a scale.
No, it's a.
That's a vector because you change the direction.
There you go. It's a vector.
Anything.
It has direction. Now, when you ride the Ferris wheel, maybe y'all like the Ferris wheel.
Yeah.
I can't stand it. I'm afraid of heights. Makes me sick. I can't stand on the ground and look it up. When I stand up on the ground and look up, I can almost puke on the ceiling. All right? So, riding in an elevator sometimes can make me queasy. I know. I'm afraid of heights. I admit it.
That's why you're
I
on
hate elevators.
one floor.
Period.
Not up there.
When I go to a hotel, I tell them I don't want to be above 4th floor. All right? That way, if I decide I can't manage the elevator, I'm not going to have a heart attack doing the stairs.
You ain't gonna have a one way down.
That's true. All right, so if we look at a Ferris wheel. Those of you who like to ride, you go in a circle. Are we accelerating when we ride the Ferris wheel?
Yes.
No.
Yes.
Yes.
Because what are we doing constantly?
Accelerate. You slow down. You
We're turning. So what happens when we turn?
You slow down because you go.
You say the same speed.
We're staying the same speed, but what are we doing?
Moving.
We're moving and changing the direction. If we're changing the direction, we are automatically doing what? Accelerating. All you have to do to accelerate is change the what? Direction. Okay? Change the direction, you accelerate. You can walk in a straight line at constant speed and turn and change your direction. You accelerate. Walk in a straight line at constant speed. Change the direction. You accelerate. Same thing on a Ferris wheel. I can put you on a Ferris wheel for an hour and let the guy run you at constant speed for an hour. You're changing your direction. Up, across, down, across, up, across, down, across. You are changing your direction. You are accelerating.
What about a roller coaster?
See, that one's going to change its speed up, down, and direction also. So you'll accelerate the whole time you're on a roller coaster. Okay? But a Ferris wheel, you're going to get a constant speed. So at constant speed, you can also accelerate if you change your direction. Okay? What time do I have? I have 1:16. All right. Not going to do the graphs. I have to save that for tomorrow. Let's talk homework because y'all need some math tonight.
No.
I know.
I
All
have
right.
enough at back homework.
Somebody hand these out for me so I'm not slow. Alexis is making fun of me in my hands and handing out papers.
I'll do it.
It's okay. I understand. My kids do it too. Come see me. Now, the math sheet that I'm handing out